Welcome to Remedial 1 YouTube channel. This is where we help students prepare for their WASSCE exams. And I have a question on the screen. The table shows a record of the length of time to the nearest minute of each lecture attended by a student during a particular week. This is the length of time for the lecture in minutes. This is frequency, and then this is frequency density. So from 50 to 53 minutes, we don't know the frequency. 54 to 55 minutes, we don't know the frequency. 56 to 59, the frequency is 30. And then 60 to 67, the frequency we don't know. And we have the frequency densities. So in the first place, we have been asked to find the values of x, y, and z. In the second part is to draw a histogram for the table. So let's find the values of x, y, and then z. Now you have to remember that frequency density is equal to the frequency of the class over the class size. Now in the first 50 to 53 minutes, the frequency density is 5. We don't know the frequency, and then we know the class interval. Now we need the class size. How do you find the class size? You find the class boundary of this. Now the class boundary of 50 to 53 is subtract 0.5 and then you add 0.5. So this one will be 49.5 to 53.5. So when you find the difference between the lower class boundary and the upper class boundary, the class size is going to be 4. So for 50 to 53, class size is 4. So we just substitute them in our formula. So frequency density. So for that, 5 is equal to the frequency, which we don't know, x, over the class size, which is 4. So our x will be 5 times 4, giving us 20. Okay. Now for 54 to 55, the class size, as I said, you need to find the class boundary. The class boundary will be 53.5 to 55.5. So the difference between the lower and the upper class boundary, class size becomes 2. And then we substitute it in the formula. So 13, which is the frequency density, is equal to y over the class size. The class size is 2. So y will be equal to 13 times 2, which is 26. Now let's move on to the fourth column. We have 60 to 67. So the class boundary will be 59.5 to 67.5. So the class size, when you find the difference, you're going to get 8. Frequency density is equal to its frequency z over the class size 8. So z will be equal to 1.5 times 8. And what is 1.5 times 8? Which is giving us 4. Okay. So these are the values of x, y, and z. Let's summarize the table. So now we have a complete table. When the frequency is 20, the density is 5, 26, 30, and then 12. And there's one thing that we need to know, the class size. Well, that is what we are going to use to draw the histogram. The class size here is 4. This is the class size. This is 4. This is 2. Also 4. Then this is 8. These are the class size. Now how do we plot the histogram? Bear in mind that the class size are not the same. So we have an unequal class interval. And with this, we need to use the frequency density to plot the graph. Okay, so let's go to the graph. So this is the graph. Now, looking at our data here, that's the frequency density. The highest value is 13 and the least value is 1.5. So what will be the appropriate scale? So the appropriate scale will be 2 centimeters to 2 units on y-axis. And don't forget to break your graph. So for those candidates who are going to write the exams, if you don't break it, you're going to lose all the marks here. So the first thing is to break it. Why are we breaking it? Because from 0 to 49.5 it's not the same as from 49.5 to 51.5. So when you make this symbol here, the break symbol here, it will cover the deficit on this side. Here the intervals are equal, so you don't have to worry yourself. Okay, so let's come to the graph. Now on the table, now to draw the class boundaries are there, 49.5 to 53.5. Now how do we plot the histogram? So on the vertical axis, the y-axis, we have frequency density. And then on the horizontal axis, we have the length of time. Now, from the first boundary, from 49 to 53, the class size is 4. So you need to go through all the class size. And then the least is 2. So you have to decide that I'm going to use 2 centimeters bar for every 2, a class size of 2. This is 2 centimeters. So if we are saying that for every 2 centimeters, let's use it for a class size of 2. Care must be taken here, but most students are found wanting when it comes to drawing this graph. So you decide that for every class size of 2, I'm going to use 2 centimeters bar to represent a class size of 2. Okay. So the first class boundary, the class size is 4. So which means that we use 2 bars. So from 49 to 53. And then the frequency density was 5. So this is 5. You draw your 5. Okay. Then the next one, the frequency density is 13. And the class size is 2. So if it is 2, yes. So this is 13. And then we said that for every class size of 2, you will use 1 bar. So that is our bar. The next frequency is 7.5. This is 7 and 7.5 will come here. The class size is 4. So it will take 2 bars. So that is it. And then the last one, the frequency density is 1.5. So this is 1.5. This is 1. So 0.5 will be somewhere here. And the class size is 8. So if the class size is 8, it means that we need 4 bars. Class size of 2, we are using 1 bar. So if it is 8, then we are going to use 4 bars. So 1, 2, 3, 4. So that is it. So that is our graph, our histogram. Viewers, thank you very much for watching this video.